Number 42. So basically they tell you that you have a semicircle, the radius is given, and you have a rectangle inscribed. So this is what I would do. So let's say we have a semicircle, looks like this, the radius is 8, and we inscribe a rectangle, and based on the given information, this side is laying right on the diameter, right on this side. So let's say this length is x, okay? Then what is this? This length is y, but I want to express it in terms of x. So in order to find that y, I guess I need to come up with some kind of equation that represents this the circle, half of the circle. So normally, if we had a circle like this, what would be our equation? X squared plus y squared equals radius squared. Radius is 8, so 8 squared, right? But we're dealing with half of this circle. You know what? Since it's in the first quadrant, we're dealing with positive values. So then, you know what? We can just solve for y. When we solve for y, we get 64 minus x squared. And normally that would be plus or minus, but we're not interested in the bottom part of this circle. So we're going to take just the positive y values. So that would be 64 minus x squared, correct? So that's the equation. Now, back to this point right here. So if this distance is x, and this length is the y length, but what is your y? The y is this. So the point up here has coordinates x, comma, the square root of 64 minus x squared. So if you know what x is, you can always plug it into your y expression for x and get your y coordinate. Now, it says find the maximum area. No, what's the maximum possible area of the rectangle? So in order to find the area of the rectangle, we do length times width. So in this case, you're going to do, well, the whole thing would be 2x, right? You double this distance. So area equals 2x times the y length is the square root of 64 minus x squared, right? Okay, so to find the maximum area, so you have to deal with the derivative. So find the derivative of a, product rule. So it's 2 times the square root of 64 minus x squared plus 2x and 1 over 2 square root of 64 minus x squared. The chain rule gives you negative 2x. So negative 2x. So we can cancel this. And we end up with 2 square root of 64 minus x squared, negative. And we have 2x squared on the top and a square root of 64 minus x squared on the bottom. Now, what is the maximum possible area? So let's set that equals to 0. So derivative equals to 0. So what was that? 2 square root of 64 minus x squared minus 2x squared over the square root of 64 minus x squared equals to 0. Common denominator, so we get 264 minus x squared, right? Because we're multiplying by the square root of 64 minus x squared. Minus 2x squared all over the 64 minus x squared equals 0. Now notice that on the bottom here you have this expression and it can be equal to 0. What makes that 0? X equals plus or minus 8, right? So these are the bad values. All right, so let's see. The top expression set equals to 0. So you get 2 times 64 is 128 minus 2x squared minus 2x squared equals 0. 128 equals 4x squared. divide both sides by 4, and I believe we get, what is it, 32? 32. So x equals plus or minus the square root of 32. Obviously, you're going to reject x equals negative the square root of 32 because we don't consider negative length, obviously. So x equals the square root of 32. So that would be the value that gives you the maximum area. Now I'm looking at the answers. See, they try to trick you here. Be careful, because they're talking about the maximum area, not the x, the maximum dimension, maximum value of x. So you just take this square root of 32 and you have to plug it into your area formula. And the area formula was, I'm going to circle it in green, this. So if you plug in square root of 32, you get 2 times the square root of 32, and then square root 64 minus square root of 32 squared is just 32. So you get 2 square root of 32, the square root of 32. And square root of 32 times itself is 32 times 2, you get 64. And that would be option E.